People talk about the cloud like it's this invisible thing floating somewhere out on the internet. But physically, the cloud is mostly giant buildings full of computers. And once you start looking underneath modern technology, you realize that there's an enormous amount of real world infrastructure hiding behind very simple interfaces. Every TV show stream, online game, AI prompt, and cloud backup all eventually run through physical machines somewhere. And those machines generate so much heat that cooling them has quietly become one of the biggest engineering challenges in modern computing. Today we're going to break down what modern data centers actually are, why they generate so much heat, why water becomes part of the story, and why communities are starting to ask hard questions about where these facilities should be built. Because the internet feels abstract, but the infrastructure behind it is very physical. Let's set sail. One reason this topic can feel a little strange is that most of us interact with software, not infrastructure. We open an app, stream a movie, scroll social media, or save a file, and something happens. It's all just in the cloud. And we rarely think about where that work in the cloud is actually taking place. But the cloud isn't a place. It's infrastructure. And a huge amount of that infrastructure lives inside data centers. Those buildings full of computers are where much of modern computing actually happens. If you're hearing a lot about data centers lately, it's probably because of AI. And AI is certainly one reason data center construction has accelerated in recent years. But it's important to understand that data centers didn't suddenly appear because of AI. Long before AI became a household topic, data centers were already supporting much of the internet we use every day. Email and websites, social media, online shopping, video streaming, cloud storage, online banking and gaming, and business software all happen in data centers. So AI didn't create data centers. AI is just one of the newest and fastest growing workloads running inside them. And that's important because it's easy to hear about a new data center project and assume it's entirely about AI. But every time you scroll social media, stream a movie, shop online, or play an online game, you're already relying on data center infrastructure. Most of us have been using data centers every day for years. We just don't usually think about them. So this really isn't about AI. It's more about the infrastructure. And once you start looking at data centers as infrastructure, a lot of the discussions around electricity, cooling, water use, and community impact start making a lot more sense. One of the most important ideas is that computers are also heat machines. That sounds strange because we think of them primarily as information machines. But physically, almost every watt of electricity going into a computer eventually becomes heat. Not because it's broken or that the system is inefficient. That's just what happens when electricity moves through billions and billions of transistors. At the scale of a laptop, that heat is manageable. Your fan spins up, the bottom gets warm, and it's not really a big deal. But now imagine scaling that same concept up to tens of thousands of computers, all of them running continuously inside giant warehouse-sized buildings. And that is especially true with modern AI systems. AI hardware uses a lot of power, and that also means it generates a lot of heat. And at that scale, cooling stops being a computer problem, and it becomes an industrial engineering problem. A good way to think about it is that a data center is basically a giant electric heater that also performs computation and stores data as a side effect. And once you start thinking about it like that, the rest of the infrastructure starts making a lot more sense. So the next question becomes, how do you cool all of this? And that's where water enters the story. Water is extremely good at moving heat. As a result, many facilities circulate cooled liquid through systems that absorb heat from the servers. And people sometimes assume, well, why not make the whole thing a closed loop? And parts of it often are. But eventually, the heat still has to leave the building. The goal is not really to destroy heat, it's just to move that heat somewhere else. Cars do this too. A car radiator moves heat from the engine into the outside air. And data centers can also dump heat into the air. But once the number of computers reaches a certain point, the math starts changing. Because fully dry cooling systems can become larger, more expensive, less efficient, and more power hungry. And that's especially true in hotter climates. And this is why many facilities use evaporative cooling systems. Evaporation removes heat extremely efficiently. But the trade-off is that evaporated water leaves the local system and must be replaced. And that's what people usually mean when they say a data center consumes water. And depending on the size of the facility, that can become a very large amount of water. Data centers are often talked about like they're fundamentally different from industrial infrastructure. But in many ways, they really aren't. Factories consume resources and produce economically viable outputs. Data centers do the same thing. The product is just digital instead of physical. Instead of cars or appliances or steel, the output becomes cloud services, AI processing, search results, video streaming, and online infrastructure. The output is bits instead of widgets. But the physical infrastructure underneath is still important. Power consumption, water use, land use, and grid strain all make a big difference. And viewing data centers as industrial infrastructure leads to healthier conversations, because then we can stop treating them like magic and start evaluating them the same way we'd evaluate any large industrial project. It's important to note that this doesn't automatically make data centers bad. Modern society absolutely depends on them. The internet wouldn't function at its current scale without massive computing infrastructure. But communities also have legitimate questions when projects become large enough to affect local resources, especially water. Because at a certain point, the discussion stops being about technology and starts becoming a question of resource allocation. If a region is already water stressed and a facility adds significant industrial demand, people are going to ask whether that's a responsible fit for the area. And honestly, that's a very reasonable conversation to have. And not from a not in my backyard mindset, but from a sustainability and infrastructure mindset. Because ideally, infrastructure should fit the carrying capacity of the region where it's built. And this standard should apply consistently across factories, industrial plants, warehouses, manufacturing, and data centers. Technology shouldn't automatically get a free pass simply because the product feels invisible. The good news is this isn't a static problem. Data center operators know that water use is under scrutiny, and many are working on ways to reduce or optimize it, including different cooling designs, more efficient equipment, and systems that use outside air when the weather cooperates. And that's in addition to better approaches that already exist. Some facilities use reclaimed or non-potable water instead of drinking water. Some use hybrid cooling systems. Some are intentionally built in colder climates where cooling becomes easier and more efficient. And some systems are even starting to reuse waste heat. Because once you realize that a data center is basically a giant heat-producing machine, it becomes very reasonable to ask, can some of that heat actually be useful? In parts of Northern Europe, some facilities already feed waste heat into district heating systems for nearby buildings. And we can expect to see more experimentation like that in the future, especially as AI systems continue to need more and more power. Because ultimately, the internet may feel abstract, but the infrastructure underneath it is one of the largest physical systems humans have ever built. And understanding those hidden systems help us think about technology in a more grounded way, not as magic, but as engineering. The cloud feels invisible because the interface is simple, but underneath that simplicity is an enormous physical infrastructure system made of power, cooling, networking, land, water, and engineering trade-offs. And the more we understand those systems, the better conversations we can have about how technology should grow responsibly. Until our next voyage, I wish you smooth sailing.